Today I am going to present how to determine the deflection of a pin jointed truss by unit load method. So you know what is truss? A truss is an articulated structure composed of straight members arranged and connected in such a way that they transmit primarily axial forces. A truss consists of the number of members connected at the joints called as pin jointed truss. You know what is pin jointed truss? Already we have discussed. It is assumed that the pin jointed truss carry axial forces only. And you know a truss which satisfies the equation m is equal to 2j minus 3 is known as perfect truss, where m is the number of members and j is the number of joints. You know that is from the statically determinate and indeterminate structure. So already we have derived this one when the number of member is equal to the 2j minus 3. So this is here called the perfect truss. If m is not equal to 2j minus 3, this is your imperfect truss. You know a perfect truss is one which has just sufficient members to keep the truss in equilibrium under any external force acting at its joint. And the truss is a structural member that is assembled in such a way that the forces are applied only at the ends. Where you have to apply the force in the truss, you have to apply the force in the truss at the joint, at the ends. These are the classification of truss. So here you see this is your plain truss, space truss, perfect truss, imperfect truss, simple truss, compound truss, and complex truss. These are the different classification of truss. Plain truss, you know, this is your statically determinate plain truss and statically indeterminate plain truss. Already we have discussed in the statically determinate and indeterminate structure. This is the plain truss. The statically determinate plain truss. What is statically determinate plain truss? When m plus r is equal to 2j, the number of unknowns is equal to the number of statical equilibrium equations. That is called the statically determinate plain truss. What is statically indeterminate plain truss? When the number of unknown is greater than the number of static equilibrium equation, and that is called the statically indeterminate plain truss. Similarly, this is space truss also. Statically determinate space truss and statically indeterminate space truss. And perfect truss, already you know that is perfect truss. When m is equal to 2j minus 3, and this is your called the perfect truss. And when m is not equal to 2j minus 3, this is your imperfect truss. Then simple truss, compound truss, and complex truss. So here coming to this plain truss, you know that is the plain truss, already we have discussed. If all the members lie in one plane, it is called plain truss. It is two-dimensional structure. And you know what is space truss? A three-dimensional truss is called the space truss. So the space truss is a three-dimensional structure. The basic form of a truss is a triangle. You know already. So the basic form of a truss is triangle formed by three members joined together at the common ends, forming three joints. Such a triangle is clearly rigid. Another two members connected to two of the joints with their far ends connected to form another joints form a stable system of two triangles. If the whole structure is built up in this way, it must be internally rigid. Such a truss, if supported suitably, will be stable. You know, so in a basic form of a truss, this is a triangle. When you will add another two members and one joint, and that becomes the triangle, and that is also the basic form of a truss. So the two triangles. So the truss has to be supported in general by three reaction components, all of which are neither parallel nor concurrent. Such a truss is called the simple truss. The reaction components of the truss is neither parallel nor concurrent, and such a truss is called the simple truss. Here you see, this is the simple truss. The triangle is the basic form of a truss. So here three members and three joints. If you will add another two members and one joint, that becomes the simple truss. Here there is two triangle. If you take another two members and one joint, then that becomes the three triangle. Then that becomes the three triangle. This is also a simple truss. If you add another two members and one joint, and that becomes the fourth triangle. That will also a simple truss. So the basic, the triangle is the basic form of a truss. Here you see, this is the hinge support and this is the roller support. So at the roller support, the reaction is always perpendicular to the roller base. But in the case of hinge support, the reaction is passing through some angle. So here you see, so this is neither concurrent nor parallel. The reaction component, the two reaction component is neither concurrent or nor parallel to each other. That's why this truss is called the simple truss. Simple truss. This is from this definition. The truss has to be supported in general by three reaction components, all of which are neither parallel nor concurrent. Such a truss is called the simple truss. Yes. So this is neither parallel nor concurrent. So this truss is called the simple truss. And the basic form of a truss is the triangle. So if you add the number of triangle, here this is one triangle, this is another triangle, this is one triangle. So these are the number of triangles. So this is also a simple truss. Then what is statically determinate truss? A truss which possesses just sufficient number of members to maintain its stability and equilibrium under any system of forces applied at joints is called statically determinate and stable truss. You know, in the case of statically determinate truss, 2J is equal to M plus R. This is the number of unknown forces and this is the number of joint equilibrium equation. This is number of joint static equilibrium equation. If the number of joint static equilibrium equation is equal to the number of unknown forces, then this is called the statically determinate truss. 2J is equal to M plus R, where J is the number of joints, M is the number of members, and R is the number of reaction components. When M plus R is equal to 2J, then that is called the statically determinate truss. Then what is statically indeterminate truss? What is statically indeterminate truss? If the unknown is more than the number of equilibrium equations, the truss is called the statically indeterminate truss. Here you see, so this is the number of unknown forces and this is the number of equilibrium equations. This is the number of equilibrium equations. If the number of unknown forces is greater than the number of equilibrium equations, or the number of equilibrium equation is less than the number of unknown forces, so this is called the statically indeterminate truss. So in the case of statically indeterminate truss, you can find out what is the degree of static indeterminacy. How will you find out the degree of static indeterminacy? Because the M plus R is the number of unknown forces and 2J is the number of static equilibrium equations. If M plus R minus 2J, so the degree of static indeterminacy that you can find out, then you will take the difference between the number of unknown member forces and the number of static equilibrium equation. That is M plus R minus 2J is equal to the degree of static indeterminacy. The degree of static indeterminacy is equal to M plus R minus 2J. This is already we have discussed in the statically determinate and indeterminate structure. What is compound truss? Here you see, this is one simple truss. This is this side. This is one simple truss, and this is also one simple truss. When the two simple trusses are connected by means of bar or pin connection, the reactive components of the support, if that is a non-concurrent, non-parallel, and that truss is called the compound truss. That truss is called the compound truss. Here you see, so compound truss, simple trusses are always stable if supported in a suitable manner. If two simple trusses are connected with a set of bars or pin connections which provide non-concurrent, non-parallel reactive components to each simple truss, then the system is stable. Such a system is termed as a compound truss. So this is your compound truss. When the two simple trusses which is connected and by means of set of bars or pin connection, and in which the forces, the reaction component is your non-concurrent and non-parallel, then the system is stable. Then this system is also stable. This is also called the compound truss. Then what is complex truss? A truss which cannot be classified either as a simple or compound is a complex truss. Here you see, this is the complex truss. This is the complex truss. This is the support. This is the support. One is your roller support, and another one is your hinge support. This is the truss. So here you see, each joint there is your three members. But here this is not the joint. There is no connection at the intersection. Here you see a truss which cannot be classified either as simple or compound is known as the complex truss. One identifying mark to know a complex truss is to note that there is no joint where only two bars meet, although the truss is statically determinate. Here you see at each joint there is your three members meet. At each joint there is your three members meet. Not a single joint where the two members meet. Not a single joint where the two members meet. But at each joint there are three members meet. So this type of truss is called the complex truss. This is generally not used in the structural application. So now you are clear. So what is compound truss? What is simple truss? What is plain truss? These are the plain truss, then the space truss, perfect truss, imperfect truss, simple truss, compound truss, and complex truss. Then you know, so these are the points you have to remember. What are the zero force members used for analysis of the truss? Because you see, at any joint, if there are two members meet, at any joint there are two members meet, so the force in that member is equal to 0. In the analysis of the truss, so here also this is the joint, here also two members meet, so you have to take this is the forces in this member is 0. And here you see that this is the joint, and here three members meet, and these two members are in same straight line. These two members are in same straight line, and this is the third members. So the force in the third member is equal to 0. Here also you see this is a joint, three members meet, and these two members is in the same straight line. This is the third member, so the force in this member is also 0. Here also you see this is the two members in the same straight line. This is the third member, and the force in this member is 0. Here also this is two vertical members, and this is one horizontal member. So meeting at a joint. So this is same straight line, and this is the third force. This is the third member. So here the force is 0, and here also the force is 0. So these are the different zero force members. Directly you can use during the analysis of a truss. To know deflection of pin-jointed plain truss by unit load method. How you will find out the deflection of pin-jointed plain truss? By unit load method. Unit load method can be used for finding deflection of a single joint at a time. So you can find out the deflection of a single joint at a time using the unit load method. The deflection of the truss can be determined by delta is equal to integration of P dash E into dB, where delta is the displacement of the point in the direction of unit load applied, and P dash is the stress due to unit load, and E is the strain due to applied load. So this is you have to find out from the unit load, and this is E, the strain. This you can find out from the applied load, and this is the displacement at the point in the direction of the unit load applied. So where you want to find out the deflection, so at that point you have to apply the unit load, and at that point you can find out what is the deflection. In the case of pin-jointed plain frame or pin-jointed plain truss, there is only one type of stress, that is direct stress. You know, in the case of pin-jointed plain frame or pin-jointed plain truss, there is only one type of stress, that is your direct stress. You will find out what is the direct stress, because the axial force is transmitted through the members. So you have to find out what is the axial force in the members, that is your direct stress. So this stress may be different in different members. This stress may be different in different members, but is constant at all point in the members. Here you see in the truss. So at because this is one member, this is one member, this is one member. These are the different members, but at each point the stress is your same. At each point of the member, the stress is same, but in different member, the stress is your different. But in a same member, but at each point, the stress is your same. The stress may be different in different members, but is constant at all point in a member. Hence, the integration P dash E dV is equal to summation of P dash E into A into L, because this is the change in volume, so that you can for the total truss members, you have to take the summation of all the members. So summation of P dash into E into AL. This is for all the members of a truss. The stress may be different in different members, but is constant at all points in a member. Hence, the integration of P dash E dV is equal to summation of P dash E AL, where summation is to cover all the members of a truss, and A is equal to cross-sectional area of the member, and L is equal to length of the member, and P dash, this is the stress due to unit load, and this you can find out small k by A, divided by A, and K is the force in the member due to unit load, and E is the strain due to given load. So this is E is your strain due to given load, and P dash is the stress due to unit load. For the stress due to unit load, that you can find out. So what is the force in the member due to unit load divided by the area? This is small k by A. So k by A is the stress due to unit load, and this you can find out. First you have to find out what is the forces in the member due to unit load. Then if you divide by area, then you will get what is the stress due to unit load. This is. So here you see the strain. This is the strain is your due to given loading. So E is equal to P by A into 1 by E. So this is the force in the member due to given loading. P is the force in the member due to given loading. This is the area of the member, and into 1 by E is equal to P by A. So this is the strain. This is your strain due to the given loading. The strain is equal to force in the member divided by area of the member into the strain is equal to force in the member divided by area of the member into the modulus of elasticity. Then you can find out what is the displacement at a point in the direction of unit load using this relation. So delta is equal to, you know here. So this is the deflection at a point of the truss. So P dash E dV. So P dash integration of P dash E dV is equal to summation of P dash E AL. So what is P dash? So P dash you got here. This is K by A. So here you put summation of K by A, and here you know this is E, the strain due to given loading. E the strain due to given loading. So here you know what is the strain due to given loading. This is your E is equal to P by A. So here you put P by A into A into L, into A into L. Into L. Then you can find out what is the displacement or what is the deflection at a point of the truss in the direction of unit load. So delta is equal to summation of PKL by A. PKL divided by A1A cancel each other, then the remaining is your AE. So the deflection at a point in the direction of unit load is equal to summation of PKL divided by A. The method needs analysis of the truss twice, once with the given loading to get P terms, and second time with the unit load to get K terms. So what you have to do in the analysis of the truss for deflection. So here you have to see, so the deflection at a point is equal to summation of PKL by A. So here you have to find out the P the forces in the member due to the applied load. So you have to find out these forces in the member due to the given loading. Then here you see this is the K, this is the forces in the member due to the unit load. This is also you have to find out. So you have to analyze the truss twice. First with respect to the given loading, so you will get the P terms, and second with respect to the unit loading, and so you will get the K terms, the forces K in all the members. Then you know what is the length of the member, and you know the area of the cross section of the member, and you know what is the modulus of elasticity. Then you can find out what is the displacement at a point in the direction of unit load. Where you need the deflection, so at that point you have to apply the unit load. First you have to analyze the truss by considering the external load system, and you have to find out what are the forces in all the members of a truss. Then what you have to do, you have to remove the external force, and you have to apply the unit force at a point where the deflection is required. Due to that unit load, once again you have to find out the forces in the members. Once again you have to analyze the truss, and you have to find out what are the forces in the members due to this unit load. So that is your K. Then after getting the P and K, then you know this formula. So using this formula, you can find out what is the displacement at a point in the direction of unit load. At the required point, you can find out what is the deflection at the required point. So this is the sign conventions you have to use. If the force in the member of the truss is tensile in nature, the arrow mark should be away from the joint. If the force in the member of the truss is compressive in nature, the arrow mark should be towards the joint. If the force in the member is compressive nature, you have to give the arrow mark towards the joint. And if the tensile in nature, you have to give the arrow marks away from the joint. So this is you have to remember. For tensile, you have to give the arrow mark away from the joint, and for compressive nature, you have to give the arrow mark towards the joint. Use tensile force in the member of the truss is positive, and compressive force negative. You have to take the tensile force is positive and compressive force is negative. In the analysis of each joint, use right arrow mark positive. Use right arrow mark. Right arrow mark, this side arrow mark is positive, and left arrow mark you take negative. In the analysis, when you will resolve the forces in horizontal direction and vertical direction, so that case you have to take the right side arrow mark is your positive, and left side arrow mark is negative. Similarly, take upward arrow mark is positive, and downward arrow mark is negative. And you take the clockwise moment is positive, and anti-clockwise moment is negative. So this is, you have to remember this, the sign conventions for analysis of the truss. These are the procedures you have to remember. Procedure for calculating truss deflection. These are the procedure you have to remember. The first, calculate the real forces in the member of the truss either by method of joints or method of sections due to externally applied forces. What are the forces given in the truss? So by considering that force, you have to find out what are the forces in the member. You know there is the method of joints or method of section. Using these two methods, you can find out what are the real forces in the member of the truss due to the external applied forces. Then calculate forces in the member of the truss. Consider the virtual load system such that only unit load is applied at the joint in the horizontal or in the vertical direction where the deflection is required. If you want to find out what is the horizontal deflection, so you have to apply the horizontal unit load at that point. If you record the vertical deflection at a point, so you have to apply the vertical unit load at that point. Then by considering the unit load, you have to find out what are the forces in the member. This is your K. Then you know what is the length of the truss member. So this you can calculate from the geometry of the truss. Then you know what is the area of truss member. So this is your A. This is your given in the problem. The area of the truss member is given in the problem. This is your A. Then you know what is the modulus of elasticity. This is also given in the problem. So this is your E. Then you can find out what is the displacement of the joint in the direction of unit load. So this is the displacement at the joint in the direction of the unit load. So this displacement you can find out using this formula. Delta is equal to summation of PKL divided by A. So this is the displacement you can find out at the joint in the direction of unit load. Now we will stop here. So in next class we will discuss the problem, how to find out the deflection of the truss at a point in the direction of unit load.